Okay, so we're back and I've done nothing. I was waiting for you. So hopefully you've done something and you can check and see if your answer is the same as the one that I'm going to get. But you can either take this vertex that we just found and put it in for h and k, and then take one of your intercepts, right? If this is an intercept that's 1, 0, or 3, 0, and plug that in for your x, y to solve for a. I think that's the harder or the more time-consuming way of doing it, but you can do it, right? X plus 1 equals a times x minus 2 squared. Put in 1, 0. When x is 1, y is 0. 1 equals a times 1 minus 2 squared. Well, you can see here, negative 1. 1 minus 1 is negative 1, but negative 1 squared is positive 1, so a equals 1. But that's not the quadratic equation, that's just a. So then you'd have to go back, substitute it in here, and then resolve. So y plus 1 equals 1 times x minus 2 squared. So I move my my 1 to the other side while expanding the x squared minus, the x minus 2 squared, which becomes this. And then I move this 1 to the other side, which becomes minus 1. I combine my like terms, I get x squared minus 4x plus 3. Okay, technically we're not really supposed to have a y in there, we're supposed to have a 0, so that's why you shouldn't use the this vertex form, sorry, I'm stumbling with my words. Why you shouldn't use this vertex form, but you can, you would just substitute the 0 in for y. Okay, what's the easier way? Well, I think the easier way is to just look at your graph. The graph is opening upward. Look at this step. We went to the right one and up how many? We went up 1. Well, that automatically should tell you instantly that a equals what? That it's just a normal relationship. That a equals 1. So we would do 0 times a, 0 equals a times x minus r sub 1 and x minus r sub 2. Well, I gave you the roots. The roots were 1 and 3. I just found a. A is 1. So it's x minus 1 and x minus 3. And then what do? I just FOIL that out. So I get x squared minus 3x minus 1x plus 3. The 1 times all of that's going to stay the same. Do I get the same thing? Yes, I do. I get 0 equals x squared minus 4x plus 3. So there you have it. Same, no matter which process you do. But notice here, one of the keys, I hope you got through this, is that your vertex is always going to be in between the two zeros, the two places where the graph crosses the x-axis. Your vertex is always in between them, so how do you find it? You find the vertex, the x-coordinate of the vertex, by taking the average, right? By taking the average of the x-intercepts. So the x-coordinate of the vertex is equal to the average of the x-intercepts. Okay, let's try our word problem. A rectangular dog kennel is to be constructed alongside a house with 60 meters of fencing. So if this is my house, then I have an x and a y and an x, and 2x plus y must equal 60. That's what this first sentence tells me. If the house serves as one side of the kennel, determine the greatest possible area that can be enclosed. Okay, well, greatest possible area. So I'm trying to find the maximum area, so it's a function of what? Well, it's a function of its dimensions. So I would find the greatest possible area if I multiplied the two dimensions to each other. Okay, x times y, length times width. But I can't have two different variables, so I have to substitute in for y. I have to use this perimeter equation so I can substitute a value in for y. So I have everything in terms of x. So I take 60 minus 2x from this perimeter equation, and I substitute it in right here. So I get the area in terms of x equals x times 60 minus 2x. So what do? I distribute that. Or maybe you don't distribute it, actually. It's going to be easier if we don't. Why? Well, if we're talking about the negative, okay, let's go ahead and distribute just so we can see what it is. So it would be 60x minus 2x squared, right? Okay, look at the letter A. -2 is equal to the letter A. The letter A is negative, which means the parabola is going to open downward. If I want to find the greatest possible area, then I want to maximize my area. Well, what is the area? The area is represented by the y value. So my y-axis is the area. I want the maximum. Well, in other words, I want the y value, right? The y value of the vertex. That's what my maximum is. It's the y value of the vertex. So what does my x-axis represent? That represents the width or length of one of the dimensions of the house, right? So it's a length or width or dimension, sorry, not of the house, but of the yard, the kennel, of the rectangle. So why did I say let's not factor it in the end? Or let's not FOIL it, or sorry, distribute. Well, if we keep it like this is factored form. How do I get, if I set that equal to 0, what am I doing? I'm finding the roots of the equation. This is 1 root is 0, and the other root, well, I do 60 minus 2x equals 0. So 60 minus 2x equals 0, therefore x is going to equal 30. So let's say this is 30. Well, if we want to find the vertex, I just said in my previous problem, the only way to find the vertex, not the only way, but the easiest way to find the vertex is by taking the average of those two. So that's 15. That's the x-coordinate of the vertex. But I don't want the x-coordinate of the vertex, I want the y-coordinate of the vertex because that represents the maximum value. So how do I find the y-coordinate if I know the x-coordinate? I simply take the x-coordinate and plug it in here. So if I want to maximize my area, I take my x-coordinate and I plug it in here. It says determine the greatest possible area. So I have to find my y-coordinate. So that's over here. My fault. So y equals 60 minus 2 times 15, so that equals 30. Okay, so now I have my dimensions, but notice this is not the y-coordinate of the vertex, so this is actually misrepresented here. The y-coordinate of my vertex is the area in terms of x. So I take my 30, I plug it in to multiply 15 times 30, right? My x dimension, my y dimension. So what is 15 times 30? That's 450. So my maximum or my y value in this graph is 450 meters squared. These are the dimensions that would produce the maximum area. How did I get the maximum? Well, it's the y-coordinate of the vertex. How did I get the x-coordinate of the vertex? I took the average of the zeros. Once I took the average of the zeros, I plugged in the x to find the other dimension. Then I multiplied those two dimensions to get the area. Okay, so think about that. Pause and think about it if you need to. Write a quadratic equation with integral coefficients having roots 3 plus or minus I root 2 over 2. This is like example number 1 on the front. So pause now and try it on your own. And I'm going to do it, and then you can come back and check. Okay, so you should have taken the sum of the two roots. Sorry, I don't know what happens when I scroll here. So you take the sum of 3 plus I root 2 and 3 minus I root 2, and the I root 2's cancel, so you get 6 over 2. So 3 plus 3 is 6. Now I didn't reduce it again because I need to wait and see what's going to happen with my C over A. And then I multiplied root 1 times root 2, and I get 11 over 4. So 9, this double negative turns into a positive 2, so it's 9 plus 2, which is 11 fourths. So if R1 times R2 equals 11 fourths, that's C over A, which means A has to be 4. I can't shrink this, I can't reduce it, because I can't have decimals in my standard form, because it says integral coefficients, which means integers. right? And so then my only option is to increase my A to become 4. And if I increase this to make it a 4, I have to multiply the top and bottom by 2 to make it increase to 4, so these A's match. So if I multiply the bottom by 4, I have to multiply the top by 2, excuse me, to make it become a 4. 2 times 2 is 4, 6 times 2 is 12. But remember, this equals negative B over A. So then I get A equals 4, B equals negative 12, and C equals 11. I plug it in, and this is my quadratic equation. Okay, try the last one on your own. Check, stop now, and then check it in a few minutes and see how you did. Okay, you should have gotten a maximum income of $3,375. Why? Okay, it says a ferry service transporting passengers to an island charges $10 per person, and they can carry 300 people per day. But the manager estimates that if the company charges $1 more, so they have an increase in fare, so here's my fare of $10, if I increase it by $1, right, that's just 1x, then I'm going to lose 15 passengers. So if I increase it by $1, I'm going to lose 15. If I increase it by $2, then I'm going to lose 30 passengers, 15 times 2. If I increase it by 3, I'm going to lose 45, etc. If I take the amount that I'm charging per person and multiply it by the amount of people that I have, that's going to give me my income, right? So I want to maximize this value over here. Well, how do I do that? Remember I said it's all relative to your vertex. The vertex is up here somewhere, and I can look at this. This is already factored form, which makes it so easy. One of my solutions is negative 10, x plus 10 equals 0. One of my solutions is negative 10, that's one of my zeros. And then my other 0 is positive 20. So I plot those and I look at the average. Negative 10 plus 20 divided by 2, that gives me positive 5. So that's my x coordinate of my vertex. The x coordinate of my vertex is 5. How do I get the y coordinate? Well, this time the y coordinate of the vertex is the income, and the only thing I have in here is just that x value, so I just plug it right in. Right, 10 plus 5 is 15, 300 minus 15 times 5, this is 225, and 15 times 225 is $3,375. And that is it, my friends. So there we have it. Well done, or I guess, yeah. And ask me questions if you have any. Otherwise, I will see you on Thursday for review. We'll see how it goes. I know we have IASAS coming up. People are traveling. We have teams to root for. But anyway, I'll see you then, and we can go over some questions. And then test next week, Monday. See you soon.